argue it from a mathematical standpoint if you're worried about
Yeah, that was the question.
anything. So how can the median, so 82C discusses, where are we at here? 82C in chapter 2, section 2.3. The median age for U.S. blacks currently is 30.9. For U.S. whites, it's 42.3. What is it, 30.9? Okay. Now, obviously, anytime you talk about something involving race, you could feel a little bit iffy about it, but this is just facts. I mean, there's still a lot of work to be done. You could argue why this might be true in two main ways. One obvious reason why the median age of whites might be higher than the median age for blacks. What's the more obvious possible reason for that? The population has nothing to do with it. The population size has nothing to do with it. Huh? Yeah. So one possibility is that now if so, let me see. I don't want to explain this. If there were a lot more younger black people, if the black people were there were a lot more younger black people, then that would bring the median age down. Is this true? Yes. What if they die younger, then there's not a lot of older, which is basically almost mathematically the same, right? In a sense. So either there's a lot more being born, or they don't live as long. Those are the two main things that would cause these numbers to be different. And both of those things are actually sort of happening, all right? Yeah, so Part C specifically says, how might it be possible for blacks and whites to die at the same age, but for the median, then that must be the other way. If they're dying at the same age, so that must mean that there are more younger black people. So, for example, now watch. All right, just to break it down mathematically. What is the median of that? 6. Now let's say this is, and just to get some nice numbers to work with, right? It's obviously not exactly got to do with that. Are you with me? Okay. If I load some more in at the bottom, what happens to the median?
Goes down.
The median gets smaller. That's equivalent to more births. That's equivalent to younger. And the same thing will happen if I erase some from the top, right? So that last question is really just saying, okay, there's two mechanisms. If one of them isn't, I didn't erase anybody up here because they live to be the same age, then the other thing must be true. There must be more down here. That's why the median is being pulled that way. So if that problem makes you uncomfortable, you can argue it from a purely mathematical standpoint. Look at them as just numbers. Okay? So we have to be able to talk about stuff like that, to be honest, but if that makes you uncomfortable, talk about it from just numerical standpoint. Yeah, what would the median here be now?
5.5.
Yeah, because 1, 2, 3, 4, 5, 6, 7, 8. So it's got to be the average of the two in the middle. So it was 6, now it's 5.5. If I loaded more here, it would be even lower. So either they don't live as long, which would push the median down, or they have more down here, which would pull the median down. Those are the two main ways to have the median lower from one group than the other group. I like it. We're not going to get into trying to solve all kinds of stuff. That's for you guys to try to get out there and try to figure out. Anything else from the homework stuff? So that was 82 in section 2.3. Anything else from homework stuff? Yes. 24? Oh yeah, so, all right, the book gives you a formula, which I am not even gonna use. But if you want to use it, that's obviously fine. But this is where you guys are so used to math being so cut and dry because you only normally get up through the lower levels where it's got to be cut and dry. Real math is not cut and dry. Okay? Statistics is the first place you see that. In statistics, it makes sense that stats is not cut and dry because stats is trying to model real life. And if there is anything that's not cut and dry, it's freaking life, right? You with me? All right. So the reason that I don't have to use that formula and the reason I can be a little bit loose about it is because for very small samples, percentiles don't have to be as precise. If I have 3 numbers, there's only 3 options or halfway in between. So what's the 80th percentile for this set of data? That's kind of a silly question, do you see? So percentiles don't... Either the sample is so small that it doesn't matter that I'm being a little loose with things, or the sample is so big so that any approach I take agrees. All right, maybe you guys get that. So what I'm saying is this. If I ask you, let me give us a few more here. It's not the same data. If I said so if I said 9 is in what percentile? That is not asking you to find the 9th percentile, is it? So this is the question that 24 is asking you. It isn't asking you what's the 37th percentile. You don't take 37% of the number. No. It's saying that number 37, at what percentile is it? So the really short way to do a percentile, and this is not perfect, and it doesn't have to be because it's such a stupid small set of data. How many numbers are below 9? 5 out of how many total numbers?
8.
8, so 5 out of 8. So rough estimate for what the percentile is. Yeah, 5 out of 8 is 0.625. So 63rd percentile roughly. And let's try it. What would P63 be for this data? 63% of... Let me make sure you guys are with me. If that's the question, the one answer I would take is 63. Just show me some work. There are 1, 2, 3, 4, 5 data points out of 8 that are below 9. 5 divided by 8, 63, roughly. Or 0.63. So 63%. So what is 63% of 8?
5.04.
5.04? That's roughly... Right? And in fact, when you get a number that's not a whole number, what do you do?
Round up.
Yeah. 1, 2, 3, 4, 5, 6. The 6th number is the 63rd. Holy shit, there you go. What's the 64th percentile? 9. What's the 65th percentile? 9. Why do I have so many repeats? Because I have so few freaking numbers. I'm hoping you guys understand this. So what's the answer? No. If you use the formula that the book gives you, you'll get a slightly different number here. But it's the same answer, really, because there's not that many things to choose from. Oh, you guys don't like that at all. That's too bad. That's just too bad. So if you want a cut and dry thing, use the formula the book gives you, throw the shit in there, and get an answer and feel good. When really what's more important is just what's the general idea of a percentile. That's what's more important, yes.
So I was thinking it was like 9 times 100 divided by the amount of numbers there is. There was like 8. And it gave me like 87.something%.
Yeah, see, that's not really good because percentile is all about place within the data. So whatever number is right here, don't you agree it's like the 63rd percentile based on what we just did, right? So if I change these to be 101, 102, 103, 106, 107, 109, 111, 114, that number is still the 63rd percentile.
Yeah.
But if you did what you just did, you get an answer that doesn't make any sense. It'd be more than 100%. Do you see what I mean? So then the value of the data point shouldn't come in at all. Percentiles are all about position of data points relative to others. It doesn't care what the actual value is. 0.9, 109, 1,000,000,009. If it's there, it's going to have the same answer. It's all about position in the list.
So, just curiosity, if you actually do take a look at like 9 is, like 9, if you do look at the values, 9 and like 14 is the max, does it work to like, doing like 9 divided by 14 to figure out like the percent of the total score? So it comes out to be like 64 point.
I know. That's a complete coincidence.
Okay.
Because, take all these hundreds away. Again, the answer shouldn't change if I make this 114, right?
Yeah.
It shouldn't change. So again, I always hate coincidences, but that was a complete coincidence, yeah. I don't always hate them. Sometimes they're interesting. When I'm trying to learn, they suck. All right. Some of you guys feel very uneasy about that whole discussion we just had, but I'm desperately trying to get you to realize percentiles and a few other things we're going to talk about don't make much sense when the sample size is really small. It's related to like the idea, what's the probability if you flip a coin it lands on heads? 50%. If I flip it once, does that 50% mean shit? No. If I flip it once, it's going to be heads or tails, right? So what's that 50% really mean if I flip the coin a lot? Half of the time it should be heads. So again, certain things we talk about don't make much sense until you get a large sample to talk about. Okay. Maybe. But again, if you're somebody who feels a little better when you're a little more grounded and there's just something to plug numbers into, the book gives you a formula, you can use that formula. That's fine. It's just making it more complicated than it really has to be. Okay. Anything else? Yes?
What would be the, for this one, what would be the median of the mean?
For this?
Yeah.
Well, the mean, how do you get the mean? Add them all up, divide by how many they are, right? What's the median going to be of those? 1, 2, 3, there were 8 8. So I don't have to use any formulas for that, whatever. There's 8 data points. The mean should be, yeah, you just go in. It's going to be 6.5. The number in the middle and the 2 in the middle is in the middle of the whole thing.
That's the median.
That's the median.
That's the median.
Yeah, median is about position. Mean is about data values. That's why the mean can be so thrown off if I put an extreme value. If I make that 114, does the median change? The median doesn't give a shit. It just says, that's the number over there. The median is still 6.5. Well, does the mean change? Oh, hell yes. Because how do you figure out the mean? You add up all the values, and I just put 100 more in there, right?
Wait, I thought median is the tilde.
Yeah, I'm trying to... All right. You guys couldn't see my... Maybe you're... It was a little bit curvy, but I didn't make it very pronounced. Yes?
Question 12.
Okay. Well, it says data value, number of cars. So what's the very first thing they tell you? 14 people said they sell 3 cars. So this is number 12. So in that statement, what's the number of cars? No. There's 65 total salespeople. 14 of them said that they generally sell 3 cars. So what do I put here under the number of cars?
3.
Not 14 cars. 14 people said. So how frequently did somebody sell 3 cars?
14.
14. There. Okay. All right.
Well, that would be this.
Anything else from homework stuff? Yes.
I'm at the same, section,
Like this?
number
15.
15.
So I have to either change this or I can change this.
No. They're not asking what's the mathematical difference. They're asking what's the difference between the ideas. Yeah.
So then this will be,
Okay. Anything else from homework?
okay.
Yes.
74, they ask about the outliers.
Oh yeah.
Yeah, so there should be 2 or 1, because I think the 99 is not an outlier.
Why not?
Because it's close to 86.
It's 13 away from 86.
Yeah, here the same. How do you think it's far away on here?
Yeah. Okay. So in that problem, I would accept if you just said one of them, because there's one that's obviously an outlier, but 99 is a potential outlier too. But if you don't list that one, I'm not going to take points off. Yeah. Yes. Where are we?
The same problem that you just asked.
Yes.
Now that you extend me,
Yes.
I think 5 through 9, and add a 10, and then represent 10 because 99 is so close.
You don't have to add a 10. Yeah. So if your data is 51, 62, 74, blah, blah, 95, you do not need 0, 1, 2, 3, 4. No. Why would you put that? You start at 5 to 9. And if there are no 80s, you still put an 8 because that's in the range you're looking at. I like it. But there's no reason to put these. If I don't put them, then I understand there was nothing there. I don't have to show, hey, there's nothing there. I like it. I like it. I like it. Okay. You all seem appropriately oppressed right now. Oppressed, depressed, all kinds of pressed. All right. Anything else from homework before we get back into where we left off last time?
76B.
Well, I'm sorry. Which one? 76. B.
The B, yeah.
Okay.
Not as 6 as 0. It doesn't. I'm not sure if it's still clear.
So if you're, so real quick, if I had classes 0 to 1 and then frequency 2 to 3, right? If I did, I'm working backwards here. What would this look like here? Let me start here. What would, if I had 2 to 3 as a class, what do I put on the scale here? 1.5. 3.5. All right, now let me bring this back in. No.
0.
No.
Leave it at 0.
What'd you do from 2? Didn't you have to go down a half? That's where you got it. Negative 0.5.
In that case, though, like, if you can't have negative numbers, you still want to, would you just leave it at 0?
It doesn't matter that you can't have negative numbers. I could have a class that says, I want everybody that's between negative 5 years old up to 5 years old. I can define a class that way. I don't have any negative years old people.
Yeah, like, like, you can do that. You kind of do whatever you want. You're like making the table and stuff. But as far as representing it, wouldn't it make more sense to just leave that as a 0 to be more clear in what you're like?
But then your widths aren't the same. Then you're being dishonest. So a better way to do this, by God,
0.
is to say, you could just say the midpoint. So you could actually do this and say, what's in the middle of this? So here, this would be like, there's a bar here, there's a bar here. Are you with me? But I could put that same bar here, but I could just say the midpoint. What's in the middle of 0 and 1? Yeah, 0.5. And then what's in the middle of 2 and 3? 2.5. Yeah, you could use the midpoint instead. That's more like a bar graph. There's no repeats. Yes.
Could you just put 0 to 1?
No,
Why not?
because when you're doing this, that would leave a gap between 1 and 2.
There is no 1.5, is there? We're talking about ages.
It doesn't matter. If you're the only place there should be an empty spot on this is if there's a class with nothing in it. That's what that means. If I see an empty spot, I'm like, oh, that's a class that has nothing in it. That's just the convention of how we do this because numbers have a continuous scale. So I have to kind of force them to match up. Right? Yes?
So a better way to do this, like a clear and concise way for representing things, is use like it's greater than or equal to 0, less than 2.
Yeah, so if I said this instead, 0 less than or equal to x less than 2.
Yeah, that way.
2 less than or equal to x less than 4. And then I could do 0, 2. Yeah. That is the power of this method. That's why I hope more and more you would use this way, but it's up to you guys. Now, to come back to your real question. You've been so patient. So, what if I have this here? Even I think it's like 1, 2, 3. Then I could just have a bar that I call the 1 bar. I don't have to say anything about the sides. That's the 1 bar. And then I can run into the 2 bar. Right? Then you just identify each bar, give it a name. That's the 1 bar. That's the 2 bar. Okay, maybe. Maybe not. I don't
Go
know.
back to one, would it be the rebar?
Yeah, exactly. I barred and then I barred again. That sounds like last night. What?
What you were saying, I think it's 7 to 0. Back.
Where are we at? Sorry?
Because it's quantity table thing. As it says, 7 to 0. The video side.
Yeah, 7 would be a empty spot.
Oh, graph.
Yeah. They really shouldn't have skipped it, but oh well. We can correct the book's mistakes. Okay. Anything else from homework before I get
This is 0 bar.
back into where we left off?
There's
I think
Then change it to
what I want to do.
whatever.
can't. It was already in the problem.
Yeah.
I would just rewrite it.
Did we do this one? I don't think so. We might have done this one. Shoot. There we go.
We did do that.
I want to see if we did this specific data set. All right, let's do this together. Let's do a example histogram together. Because in a regular semester, I would have given you a quiz on histograms, but then you wouldn't have got it back until the day of the test, which would have been a little evil. You guys with me? So, let's talk a little more about histograms. Let's see. Okay, I like it. Let's just make a nice little small set of data here. It's already in order for you. So on the test, obviously, I'm not going to give it to you in order. You got to order it first using your calculator, which I forgot to bring. Sorry. Shit. How do I figure out my classes to start to make this table? Yeah. Yep. So class width. How many classes do you guys want to use? 5. What's the least you could use? 5. I love it. And why are you going to use 5? Because it's really a small set of data. So if I had like 10 data points and I use 10 classes, do you see how that doesn't make any damn sense? maybe they're all going to have 1, and it's not going to show me anything about how the data is kind of clustering. Right? So that's why the smaller the sample set, the lower the number of classes you want to use.
So 5 is the minimum you ever want to use?
Yes.
Okay.
All right. So here let's use 5. So in general, it'll be the number of classes. So I'm not going to tell you how many classes to use on the test. But if I'm you, I might just go ahead and pick 5 or 6 if you're feeling 6. I don't know. So that would be 41 minus 15 divided by 5.
5.2.
Yeah. So 26 fifths. 25 fifths would be 5. 6 fifths is 0.2. So 5.2. And what do you do with that?
Round it up.
Yes, always up so that you over cover your data. So that everybody's got a home. All right.
15.
How are we feeling so far? All right. So now, set up my classes. Where do I start?
15.
If I'm you, I'm going to start at 15. Why would you do anything else? You could. You could start at 10, technically, but why would you do that, really? So 15. So what number is going to go here? 21. I'll do the other method in a second. So what number's got to go there? 20. You can always see the width this way.
Oh, is this correct?
Width is 6, that'll be 26, that'll be 27. Add 6, add 6,
Yeah.
add 6. We get it, Jeff. Now watch why the whole up and down by a half makes even a little more sense. So when I go to eventually graph this thing, I'm going to have to do what? What am I going to really put on the graph for this? 14.5? And what's 20.5 minus 14.5? 6, yeah, see? So it really is that wide. Yes?
And if you repeat the 5.2, you don't have to go to 14.5?
If you keep the 5.2, but you don't use the inequality symbols, you have to go up and down. You'd have to go up and down then by 0.05 because you have decimal. Yeah, so
I did use the inequality.
then you don't. Exactly.
Do we need to do the multiplication?
So real quick, for those of you who like the inequality way, what would your classes look like? This first class would be 15,
Less than or equal to X.
Less than or equal to X.
Less than 21.
less than 21. Then you can see the 6 from the beginning. There's none of this limit and boundary stuff, right? The limit of Jeff and the boundary of Jeff. There's none of that. I love you guys so much. Some of you guys are like, you made me feel uncomfortable, Jeff. I'm just loving the reaction of, oh my God. What the shit? So you pick a way you like better. They're both valid ways. And that's something I think, again, you guys, this is why students hate stats is we're trying to just find a way to give a visual of something. Specifics almost don't matter. A little bit they do, but not really a lot. That's why there are multiple ways to kind of do it. That also gives people wiggle room to make it look like they want to. So you got to be careful about that too. Yeah.
So would it be wrong if at the end of the equality instead of 21, I put 20.2?
Well, no, if you're using a different class width, you should be able to see the class width between those two. So if you're using 5.2, then yeah, it should be 20.2. I love it. Okay, I like it. I like it. Okay, so how do I do this next column over? No matter which way you do this, we're all going to have the same numbers here. So what goes here? Yeah, 1, 2, 3, 4, 5. And then 21 to 26. 3. 27 to 32. 2. 30, 1. 39, 4. 1. And how do you check to make sure everything looks copacetic? So yeah, 9, 10, 13 were there. How many data points were there?
13.
Thank God. Okay. This is where you kind of go, ah! If you get 12, you're like, oh, shit. Just be careful as you do this. So there are, the sum of my frequencies is 13. There you go. Yes,
So
sir.
with larger data sets, is there a way on my calculator to tell it how many values between this, in this range? Is there a way to do it with the calculator? To tell it, like, just spit back, like, how many fall into this, like, to actually tell the frequency, but, like, their ranges? Can you do it with the calculator, or do you have to do it?
Sort of.
Sort of?
Yeah. I mean, there's a very basic way to do it. You just put the cursor on one and put the cursor on the other one, and it tells you what position they are in the list, and then you just take the difference. But you can also have the calculator actually make full histograms for you. Say what? So what the hell are you doing, Jeff? Because, you know, by hand means you understand. Well, I like that. That's the first time. You're all like, whatever, man. All right. Sorry. I was thinking you were saying it might be done quick is the shit. No, it's not. It's not even a rhyme, so stop it. What am I going to do next here? Relative frequency. How do I get the relative frequency?
Frequency over
Yeah.
total.
Frequency over the total. So 6 out of 13 data points were in that first class. What does it come out to?
46.15%.
46.2? So 3 out of 13 would be about 23.1, I'm guessing. Is everybody cool with what's going on right now? There's 2 data points in this class out of 13 total. So what's the percentage of the data points in the class? That's what the relative frequency tells me is the percentage of all the data points that are in this class.
So with relative frequencies, in general, I've been using, like, at least, like, 4 6 days or 2 decimal places past it. Is it?
Well, for this case, since we're going to do this by hand, 1 decimal place is plenty.
All right.
Yeah. The more decimal places, the closer they should add it to 100%.
Yeah.
So, yeah. 2 out of 13, 15.4. And then 1 out of 13. If you add all those up,
100.1.
100.1, and that we can live with that, right? That's close enough to 100%. Why did it come out to 100.1? We rounded, and we just happened to round up more than down. Now, I generally don't make you do cumulative frequency. You do that for the homework just so you know it exists. It's not really used that often, so I'm not going to make you do it. So now take a minute and try to create the histogram for this. Your scale might look different based on which way you did this.
Do you want a frequency or relative frequency?
I love it. So make a relative frequency.
In general, the more common to relative frequency histogram than it is the equal frequency.
Yeah, that's why percentages were invented, just because they make more physical sense to us than like 0.072. 7.2%, okay, I get the idea, the pi piece that represents.
Well, yeah, as opposed to like just doing frequency.
Just doing decimals or even fractions.
Well, if you just do like a histogram just frequency, is it just that doesn't?
Oh, frequencies, but then you can't see the relative size of something, right?
I mean, it has the same basic shape.
It has the same shape,
But it doesn't like.
but it has more import to say over half of them were in this class
Got it,
instead of there were this many. All right, well, how's that relative to everybody else? How impressive is that? Percentages make that a lot clearer quick. So try, everybody understand what's happening right now? You should be attempting to make a relative frequency histogram right now. If I'm you, even if I don't understand how the hell to do it, I'm going to do something just because I'm not even going to look at it. So I used to say just draw a duck if you don't want to do it, and at least I think you're doing something.
saying you're not expecting like titles for graphs and stuff like that?
No, no title, no. Label the axes, yeah.
You don't really need.
I don't need a title. Yeah, the label of the horizontal axis should take care of that.
In general, so with science stuff, usually the title is basically just a repetition of what the labels are, kind of in a way.
Yeah,
They
yeah.
just kind of show what they're looking at.
Oh, this is
The stuff like we're trying to represent data. Is the title usually more of a summation of what
no.
what's
I just did it.
or how what is the title usually?
I mean,
We need to go all the way down to
you
zero,
could play with the
so
title to even have
show.
a conclusion that you can draw. It could be in the title, and then the graph then would be more of evidence of that.
Really just the labels have to be like what's on those
Yeah,
actually, but like
yeah. The title could actually be more than just. You could have the conclusion that you can draw from it.
okay.
I do mine like this.
I didn't really tell you what these represent, did I? So this would just be units.
You have to do it.
So this could be ages of people. This could be golf scores or look at this. Whoa. Golf scores through the first 3 holes. I don't know. This could be
So I can do 400.
anything.
That's 'cause I-
Bowling
that's why I
scores
asked
through the first 3 frames, and this would be me.
because these are home numbers, but
This would be me on a good
right
day.
here.
Huh?
is actually
No. Sorry. Never. Okay. So down there, that label has got to relate to the physical idea behind the data. So what am I going to... Now, I kind of picked a scale there. I'm going to go by 10s. I don't know if anybody went by... You can go by 6s, you can go by 8s, you can go by whatever the hell. As long as you can get up to this in a decent amount of space, you're good. So I'm going to go 10, 20, 30, 40, 50. So when I grade these, I could get people giving me entirely different things. You could pick different classes. So that's always exciting for me, but not really. It just makes it suck, but oh well. It's part of stats, is the flexibility in it. So what I'm going to put here, well, let's say based on this, what would you put? We already figured out.
14.5.
What's beautiful is once you figure out the first number,
25.
you just keep adding the width to it. Because that's what the width is. So add 6. Add 6. If you did this way, then it would be 15, 21, 27. Oh, so beautiful. I am sort of trying to tilt you in a certain direction, but you can use either way. Yes?
So if you use, when you use the unit for this one, when you use the unit quality one, and then use the 5 points, you actually have different frequencies at the end, like,
Yes, you're right. Your numbers won't match up with ours. Just because you broke it up differently, so some of these might fall into a different class. So yeah. So yours will be even more exciting for me to grade. But I'm not gonna go, you suck, and take off more. No, you did fine. The thing you're always gonna have to do though is
make sure that it's
you're gonna have to, like here, you're gonna have to make it less than or equal to. Yeah, always. If you use exactly the number, that last thing always. All right. So how high is this? No matter which way you did it, this first bar.
46.
Yeah, 46.2 roughly, so a little bit more than halfway up between those two, and so forth. Right? Isn't that horrible? 23.1. Right there. 15.4. Right there. And then 2 7.7s. Shwa, bam, bam. So that's sort of the shape of like ages in a class that I teach. Because normally most people are coming right out of high school. Maybe they're not even, this was obviously not that, but I have had somebody this age before. We do have middle school, college, I can't remember whether middle college, I can't remember what they call it. 16, 17, 16 or 17-year-olds here, but normally it's a big tall one here and then a Now for night classes, this is a little more that way a bit, But normal class is going to be, anyway. That's definitely not normally distributed. It doesn't start low, go high, and go low, in no way. This is one we would call this skewed right. Because it looks like somebody grabbed this and pulled it. I would even call it, if I kind of smooth this out, I would call it the Jabba graph, Jabba the Hutt. No? Okay, I understand. Sorry. Yes?
So the 15 wouldn't be in the center of the,
For this one.
like, actual bar? It would be on the left gap in the front.
Yeah, because that bar doesn't represent 15.
That's why it's easier.
It represents 15 to 20.
And then
So 15 should not be in the middle. That's not representing things correctly. You could use the midpoint of this. What's in the middle of 15 and 20? What's in the middle of 15 and 20?
17.5.
17.5. You go by 17.5 and then a 23.5. You could use the midpoints instead if you want to. That's the
You always
only.
leave a gap in the front.
Say again?
You always leave a gap.
Yeah, if this number is not 0, you leave a gap. Yeah. Yes?
For the y-axis, does it have to be relative frequency?
No, somebody asked me what kind of histogram, and I said, let's make a relative frequency one. If I said make a frequency histogram, we would have used those numbers, and I would have labeled this just frequency. Yeah, I like it. Don't forget your labels. I hate taking points off for just because you didn't put a word down. But I will do it still, you know. You're like, well, if you hate it, Jeff, don't do it. Okay. So any questions about histograms? I'm not going to make you make histograms after this first test. So I might make you kind of analyze a histogram that's been made already. But it's just going to be on this first test. All right? Yes?
You said this says make an Instagram and assuming relative frequency.
No. I got to tell you. If I forget to say, then you can either do either one, or you can come up and ask me, and I'll go, oh shit, I forgot to say. I'm not going to forget to say that. All right. Let's move on. So getting back into where we left off last time, I think we weren't quite done with that handout, right?
It's bars.
For some reason, I only have one of them left. Somebody do me a favor, turn off the, it should say whiteboard, and yeah, it does. Yeah. You're like, dude, I've done it before. I appreciate that. The check is not in the mail. Okay. Oh man.
No, correct means correcting. Correct means correcting. If it says like okay or revision check. Like it says,
All right.
when it says like dot okay.
Did we have these? Let's see if I can have these. No, this is the mail. Shoot. All right. I think a few of the guys started this problem. Has everybody got this? No, I'm really sorry. Didn't bring my calculators. Sitting in my house. Nice and safe. Let me do this real quick. This is exciting. How would you do that part A though? How many data points are there?
20.
5 times 4.
So you can do the first step of part A right now. Or the first step of part A, B.
20 low 7 times 20.
Who do what?
0.17 times 20.
Yeah, 0.17 to 20. I like it. Took a minute for that to get in my brain. Now just to remind you guys, once you get the data in, you can sort it, stat, sort, ascending, tell it, list 1, And then when you go back in, all your data is sorted. That's going to make percentile questions easier. So the first step on this one is I want to go 17% of 20. I want to go 17% of the way into my list. And what is 0.17 times 20? 3.4. And when I get that decimal number, I know to always go up. So the answer is going to be the fourth number. What's the fourth number?
70.
Yeah, 70. I like it. Let me see that. 1, 2, 3, 4, 70. Is everybody decent with that?
Yeah.
How do I find P87?
0.7.
Yeah, 17.4, so I round up to 18. I think we already did this, didn't we?
Yeah.
I don't know where I put my little sheet. So the 18th number came out to be,
87.
oh yeah, that's right, it was 87, that's right. How could I forget that? We even talked about, we talked about this, right?
Yeah.
35th percentile means, in this case, that you
Scored better
scored
than
higher than 35%, which you can alternate that to say you scored lower than
60.
65%. It's not a good place to be, right? Now, you might have still made a good grade.
A C.
Being in the 35th percentile does not mean your grade was bad. It just means relative to everybody else, it was worse, right? It still have been like a 98 if everybody kicked ass on the test, right? Or the quiz. So, anyway, I'm not going to write all that crap down. Now, this is what we didn't talk about yet. Here's some notes. Okay? So you can put this on this paper, or maybe in your notes would be even better. The percentile section, so 2.3 leading into 2.4. Now, if I'm 25% of the way through a basketball game or a football game, I'm at the end of the
First quarter.
So another name for P25 is Q1, the first quarter. Let that make sense, right? You could even go down to deciles. We're not going to do that shit. So 25th percentile is also called Q1. So amazingly enough, P50 is also called Q2, which is also called the median. P75 is Q3, 11. So the 5-number summary. Yes, sir.
Is it always quarter one, or does like you seem to with quadrant? Is that wouldn't make any sense to me.
Yeah, no, this isn't about quadrants. Yeah, you're good. What was I saying? Oh, the 5-number summary will always be low, Q1, Q2, Q3, high. That's the 5-number summary. What's the lowest data point? What data point is 25% of the way in? That's the 5-number summary. And box plots, yes ma'am. Q is quartile, which is really like the quarter. A quarter of the way in is 25%. That's why Q1 is the same as P25. 25 cents is a quarter. I like it. I'm not sure why some of you guys are looking at me like you want to kill me, but it's not that bad, right? What's the lowest data point up there? 65. How do you figure out Q1? Take a minute. You guys all figure out these 3 things. I'll go ahead and figure out the highest one. What was it, 79? 80, 99. Yay. I did my work. You guys too. Q1, Q2, Q3. Figure out what those things are. If you don't have a calculator, you don't have a sorted, you might want to sidle up next to somebody that has that. Be a sidler. Anybody come in and not get their quiz yet? Their quiz back?
You guys can make corrections to that.
Easy. You know how to do it. 76. Yeah. Just for $11.
One three one four good. 1112.
76. You're 77.
By the way, real quick, guys, while it's in my head, when you do corrections to anything, quiz, homework, tests, if this has already happened, it's not your fault. Don't change the original. Don't erase anything. You can correct the quiz on the back of the quiz or another sheet of paper. You turn in the corrections with the original. You guys with me? If you already erased some stuff, that's my fault. Because I want you and me to see what went wrong and then what was the right way to do it. Right?
Does he want us to find
What do you guys get for
P50
Q1?
or does he want us to find the median?
P50 is the same thing as Q2.
Q1?
Or does he want us to find the median?
71?
Those are two different answers.
76 and 83.
76?
Yeah, 83.
83? Yes, ma'am.
So since Q2 equals a median,
Yeah.
you wouldn't want us to find the median, you would want us to find the 50th percentile.
So guys, if I ask you find the 50th percentile and then I ask you find the median, what's kind of weird about that?
They're the same,
They're the same thing.
but they're two different answers.
No, they're not. Why would they be two different answers?
I don't know.
I don't know either.
That's what
So, explain to me, how'd you find the